Solve the quadratic equation in part A. Use the result to solve the inequalities in parts B and C, and write your answer in interval notation. Part A, 8x squared minus 2x minus 3 equals 0. Part B, 8x squared minus 2x minus 3 is less than or equal to 0. And part C, 8x squared minus 2x minus 3 is greater than or equal to 0. So here we have part A. We need to solve this equation. Let's see if it'll factor. And we know that this has to be a 3 and this has to be a 1. Now we're trying to get a middle term of 2, so if we were to try 2x plus 1 and 4x minus 3, that would be a 4x in the middle, for the inner term, and a negative 6x for the outer term. That gives us a negative 2x for the middle term, so we factored it correctly. In this case, we know that each one of these is set equal to 0, and here we would get the result x equals negative 1/2. Or, in this case, we get x equals positive 3/4. So there's our solutions, negative 1/2, positive 3/4. Now for B, we are supposed to solve the same expression, 8x squared minus 2x minus 3 is less than or equal to 0. Notice that the coefficient of the x squared term is 8, and that means it's a parabola that opens up. Since these are our two x-intercepts, we know that the vertex will occur halfway between them, and that this is, because it's a positive A, this parabola opens up, and therefore we're interested in that section that is between the negative 1/2 and the positive 3/4. So therefore the solution to this, which is where is this negative, that is where is it below the x-axis, is the interval from negative 1/2 up through and including 3/4. Now for part C, we are supposed to solve 8x squared minus 2x minus 3 is greater than or equal to 0. Well, knowing what we now know from solving part B, the graph opening up means, and that we're interested in where is it above the axis, it's going to be above the axis to the left of negative 1/2 and to the right of positive 3/4. So therefore, we would write in interval notation, negative infinity up to and including negative 1/2, union starting at 3/4, including the 3/4, going up through positive infinity.